Let's do another question like that. Okay, obtain Thevenin's equivalent of the circuit across A and B. So here this is the open load, right? So here the load is already removed and the question is simply find the Thevenin's equivalent of the circuit. Okay, so this is just like the previous problem, right? But and here the only difference is this is an AC voltage. Oh, I haven't marked the voltage source. The voltage source is 20 angle 0. Okay, 20 angle 0 is the voltage source. So now let's apply this using the same method. Okay, so so this is what you need to understand. For only for Wheatstone bridge, right? If you see this kind of a circuit, then you can assume that there is only two current flowing. That is I1 over here and I2, which is flowing like this. And then accordingly you can write the equation and you can accordingly find the value of I1 and I2. Then after that you can find the value of VTH. Okay, so this is VTH, right? Let me mark VTH in that case. There you have. Okay, this is VTH. So I means I'm going to find the Thevenin's equivalent across this, right? This is, so the voltage across A and B, right? Thevenin's equivalent circuit across A and B. So therefore the voltage across A and B is VTH. Okay, so now let's do this question. So equation for I1. Let me write the equation for I1. What it is? I1 into, and I, so this current I1 flows like this, right? Because no current will flow through here because this branch is open. So no current will flow through. So all the current I1 will flow through this 12 ohm and this 24J. So the current goes from 21 plus 12 plus 24J, right? 21 plus 12 plus 24J is equal to 20 angle 0 is 20 itself. There you go. Which means you have I1 is 2 plus 1 3, 1 plus 2 is also 3, so we have 33 plus 24J, which is equal to 20, which is, therefore I1 is equal to, let me see, 20 by 33 plus 24J, which is, let me see, 30 divided by, sorry, 20 divided by 33 plus 24J. 20 divided by 33 plus 24J, and you get is 0.396 minus 0.288J amperes. This is the value of I1. Okay, next the value of I2. Equation for I2. Equation for I2 is, let me see, what is the equation for I2? I2 flows through this 50 ohm, through this 30 ohm and through this 60J. So therefore I2 into 50 plus 30 plus 60J is equal to 20. Okay, so therefore I2 is equal to 20 divided by 50 plus 30 is 80. So we have 80 plus 60J, right? Or in other words, I2 is equal to, let me see, I2 is 20 divided by 80 plus 60J. I2 is equal to 20 divided by 80 plus 60J, which is equal to 0.16 minus 0.12J. This is the value of I1 and I2. So now I am going to find the value of VTH. So how do I find the value of VTH? You can either take this mesh or you can either take this mesh. Whichever mesh you want, you can take. I will take last problem. I have taken this mesh, right? Okay, so in this problem I will take the equation from this mesh. Okay, which means I am going to assume that there is a current in the mesh. Current is in this direction, right? Clockwise, is in flowing in this direction. So in that case, let me see. So here, like I said, there is a current called as I1 flowing over here, and here there is a current called I2 that is flowing over here. Let me just mark those two currents also. Okay, there. Okay, so there's a current I1 and there's current I2. So now let me write the equation for VTH in the lower mesh. So equation for VTH, you can use any mesh, this mesh or this mesh. I'm going to use this mesh. Okay, maybe you can do this problem by applying the equation for the upper mesh. Okay, I want you all to do that problem. Okay, do this, so you don't have to copy from here. Do this problem by taking the mesh from the upper side and see if you're getting the same value of VTH. Okay, so here what is the VTH? Let me see. here it is equation for VTH. Equation for VTH. Okay, so here in terms of I1, you see this the I1 is flowing downwards, but this pink current is flowing upwards, which means they are opposite of each other, which means it is minus I1 into 12 plus 24J. Okay, minus I1 into 12 plus 24J. And what about I2? Well, if you look at I2, this current and this I2 current is flowing in the same direction, right? It's flowing the same direction, so it is plus I2 into 30 plus 60J. 30 plus 60J. Okay, and what about the VTH? Well, if you look over here, this current is flowing from left to right. If you see, it's clockwise direction, right? So it is flowing in this branch, it is flowing from left to right, or it is flowing from a higher potential to a lower potential, which is what a current is supposed to do, right? It is supposed to always flow from a higher potential to a lower potential. So therefore it is plus VTH. Okay, there is no voltage source, so this is equal to 0. This is the equation. So which means from here I can now find the value of VTH, which means VTH is equal to I1 into 12 plus 24J, okay, minus I2 into 30 plus 60J. Okay, but and we know what is the value of I1. What is I1? This is I1, it is 0.396 minus 0.288J into 12 plus 24J minus what about I2? 0.16 minus 0.12J into 12 plus 24J. This is the equation for VTH. Okay, let me find the value of VTH. That is put bracket 0.396 minus 0.288J, okay, into 12 plus 24J, okay, minus, let me put one more bracket just so that I won't make any mistake, one more bracket covering these two terms. Okay, minus here also one more bracket and another bracket also, okay, just for safety, 0.16 minus 0.12J, okay, alright, into the other one is 12 plus 24J. No, the other is not 12 plus 24J, right? I think I made a mistake. Here it is supposed to be 30 plus 60J. 30 plus 60J, right? Supposed to be 30 plus 60J. Okay, 30 plus 60J. .16. Let me check if the values are correct. 30 plus 60J, and over here we have 0.396 minus 0.288 into 12 plus 24J, and your answer will be, this is your answer, which means it is VTH is equal to minus 0.336 plus 0.048J, which is equal to, let me apply polar form, which is 0.339 angle 171.87 degrees. 171.87 degrees. Okay, it's somewhat correct. Yeah. So this is the answer for VTH. Okay. Now to find ZTH, same procedure. To find ZTH, okay, Thevenin's impedance. find ZTH, what I do is, here there's already a single voltage source, all I have to do is just simply short it, so you will get these two circuits. Okay. This one I will draw like this, so it will be very easy for me to find. And over here also another one like that, right? And there's also another resistor over here. Okay, so this is 21. This is 12 plus 24J. This is 50 ohm. And this is 30 plus 60J. Okay. So, yeah. The impedance across A and B is ZTH. Okay. ZTH is the impedance across A and B. So like I said here, these two impedances are parallel to each other, right? Because this resistor is connected, one end of the resistor is over here, the other end is connected to this end, same end as this 12 ohm, and here also the same end, both of them. So which means these two elements are parallel to each other, which means parallel means the value is 21 into 12 plus 24J by 21 plus 12 plus 24J. This is the value, and what you get over here is, let me see, you get is 21 into 12 plus 24J. Okay, 21 into 12 plus 24J divided by, and here 21 plus 12 is, I will write like that itself, 21 plus 12 plus 24J, 21 plus 12 plus 24J, and you will get this is equal to 12.259 plus 6.357J. Okay, and also if you find the parallel of these two, you will get this 50 into 30 plus 60J by 50 plus 30 plus 60J, which is equal to 50 bracket 30 plus 60J, 30 plus 60J, close the bracket, divided by, here it is 80 plus 60J. Okay, 80 plus 60J. So you get is 30 plus 15J. You have 30 plus 15J, which is the value of these two resistors, which means ZTH will, now these two elements are in series with each other, right? Your impedance will now become like this, right? That is, here you have A, here you have B, and the impedance over here is this impedance, and the impedance over here is this impedance, right? This is 12.259 plus 6.357J, and here this is 30 plus 15J, and these two are in series. So therefore ZTH is equal to 12.259 plus 6.357J plus 30 plus 15J, which is equal to, so what is 12 plus 259 plus 30 is 42, right? So it is 42.259, 42.259 plus, and what about this? This is 15 plus 6 is 21, so it is 21.357 J. This is ZTH, or ZTH is equal to, if I am converting to polar form, right, 42.259 plus 21.357 J. 42.259 plus 42.259 plus 21.357 J. Okay, and this is option. Convert to polar form and you get is 47.349 and angle is 26.811 degrees, 26.811 degrees ohms. Okay, this is the ZTH. So this is the Thevenin's equivalent, that is, this is the circuit. The final circuit carries marks. Okay, so don't forget to draw the final circuit. Okay, ZTH is equal to 47.349 angle 26.811 degrees, whereas VTH is equal to 0.339 angle 171.87 degrees. Volt, this is ohms. Okay, this is the answer. Okay.